One of the features built into DDAM is the alerting mechanism. If we click on the alerts icon, we'll actually get a list of all the current alerts that have been stored in the system. These have been generated by DNS or DHCP servers based on specific criteria. So we just have a quick look, we can see that there's an alert here based on the abnormal DNS query rate. So this is an alert that's been raised because the throughput has suddenly increased and breached a certain threshold. Typically what the system will do is work out what the average query rate is. This applies both to DNS and DHCP servers. And you can set a threshold. So for instance, if the query rate suddenly increases by 100% or maybe 200% or any other kind of arbitrary figure, an alert will be generated. And this can be used to detect things like denial of service attacks or just general misbehaved clients. But the idea is to alert you to something that's abnormal, basically, with the throughput. There's other types of alerts as well. We've got an alert here which was triggered because of a serve fail response code, but there's other response codes that you can alert on from DNS, such as refused, which is when dynamic updates are refused, or things like, for instance, bad sig, which might indicate a tsig signature validation failure. And that might be because clocks are out of sync with two DNS servers. Another one is, for instance, a DNS query watch. So we can look for specific queries and trigger an alert based on that query. Now if we look at the alerts that have currently been configured, we can see these are the alerts that we're currently monitoring. If we just take one, for instance, our query watch alert here, and just modify. Basically this is a DNS query watch alert that's being applied to all existing and new nodes. So we can limit that to specific nodes if we want. And basically what's happening here is if an alert comes in that matches this query, if a query comes in that matches this string, in this case star.bind, so we're using a wildcard for the asterisk, then basically that means that an alert will be generated. Now star.bind queries are typically used for people trying to fingerprint DNS servers, so they might send a query like version.bind or authors.bind. Based on the response that comes back, it's sometimes possible to work out the type of DNS server that's being used and the version, which means then once you've identified that, you can then start hacking that DNS server for known specific security vulnerabilities. So that's quite a useful alert to have, actually, because it's not a normal query. If someone's making a query for something that ends in .bind, it's normally malicious. And you can see we've got some other alerts set up here as well. Now these alerts, as you've seen, will normally be stored in the alert log tab, but you can actually do things with these alerts. You can basically send them via SMTP as an email to somebody, or you can send them as an SNMP trap. So if we look at the configured alerting methods, you can see here, for instance, that star.bind alert has been set up with an alerting method called email poolr. So if we just modify that, basically what it means is that this particular alert will generate an email and it will go to my Gmail account. Now I've got a command prompt here, so if I start nslookup, set my query type to text and set the class to chaos. Now if I issue a version.bind query, what comes back is the version and type of DNS server that's currently being used. Now QDDNS 4.2 is actually a DNS server from Alcatel-Lucent that's based on bind. So I could look up the release notes from Alcatel-Lucent for 4.2 build 17 and find out the version of bind that's based on, and then start targeting that DNS server for specific known vulnerabilities. But the fact that I've just sent a query like that will have generated an alert to my Gmail account. So now if I go to my Gmail account, look at my inbox, we can see here straight away that an alert has been generated. You can see the IP address there, which is the IP address of my client, and the date and time that this actually happened. So that means we've got instant notification of something suspicious happening on the network. Now if I go back to the alert log tab and do a refresh, Now, what will happen is that alert will eventually appear in the alert log. It can sometimes take about 5 minutes for it to appear. Basically what happens is the DDAM master server has to go around and collect the alerts off of each of the collectors. But the alert is actually generated via email directly from the collector, which is why it's so instantaneous. Now if I just go back to alerting methods, let's say I want to add a new one, I can actually specify SNMP as well. So if I specify SNMP, then I can specify the IP address of the trap server and the port that's being used, and the community string as well. So that means we've got two mechanisms there for generating alerts. Finally, if I go back to the alert log, we've got all the usual things available. So for instance, I can do a filter. So if I just want to look at those specific start.bind alerts, we can see here a list of the alerts that have been triggered recently. And I can do usual things like moving the columns around, switching columns off, and I can also export to a CSV file. So if I just open that, open it into Excel, there we go. So we see the date and time stamp, type of alert, and the node where that alert was seen, so that's the DNS server, and obviously the reason as well. And the details will contain things like the client IP address. So that's pretty much it for alerts.